Hey there, fellow foodies. Dr. Quave here. You're listening to Foodie Pharmacology, the science podcast for the food curious. Today on the show, we're going to have a little bit of fun. I don't know if, like me, you've been watching The Last of Us on HBO, but as someone who really is interested in fungi and plants and kind of survival shows, I just ate it up. So, as the show wrapped up, I started thinking about, ways we might be able to dive into this. And I was having this great conversation with one of my buddies and colleagues, Dr. Nick Oberlies, and we came to the decision we should really chat about this. Let's talk about the mushrooms behind the show. So let me introduce you to our guest. I've got Dr. Nick Oberlies. He's internationally recognized as an expert in the chemistry of nature and medicines from natural products. He leads a team of scientists focused on the discovery of new drug leads from nature. He's skilled in the discovery, biological evaluation, structure elucidation, and optimization of natural drug leads. I also have Dr. Huzefa Raja. He's a research scientist and mycologist. That means someone that studies fungi in the Department of Chemistry and Biochemistry at the University of North Carolina, Greensboro, where he studies fungal diversity and biology. It is so great to have both of you on the show. Thanks for doing this with me.
Thank you for having us.
Yeah, thank you. It's fun. It's a lot of fun.
Yeah. Well, and this is Nick's second time on the show. We also talked about drugs from nature before, but we're going to dive in more into this kind of mushroom business. So, maybe why don't we just back up for a second before we dive into the show, and each of you tell us a little bit more about the work that we do. So we know, Yusefa, you are a mycologist. What does that actually mean? I think Nick mentioned that mycologists are kind of like unicorns, very rare to find out in the natural habitat of a lab. So, what do you actually do each day?
So mycologists are folks that study fungi, right? So I'm a mycologist. I study fungi. My interest with in Nick's lab is I'm interested in the taxonomy and systematics of ascomycetes, right? So microfungi, and I'm interested in isolating these fungi from nature. I cultivate these organisms in the lab so that we can study the chemical diversity of these microorganisms. So that's basically what I do. I'm also interested in understanding the molecular diversity that these fungi have, right? To find new species out there, right? The fungal kingdom is basically 90% unknown, right? So I'm interested in finding these unknown fungi to uncover the diversity and the chemical diversity in the lab with Nick.
That's awesome. And so when we get into chemistry, this is where Nick comes in because you are the guru of natural products chemistry and NMR. How does your job kind of play into this?
Yeah, it's great. I should also just add that I think Huzefa is a little modest, like many mycologists. The great thing about him, and I think a neat thing about our lab is it's pretty rare to have a chemistry lab and a mycology lab working quite literally, hand in glove. So his lab is right across from the hall where we're also extracting things and getting compounds out of them and all that stuff I talked about in the last episode. And the great thing about Huzefa is go hiking with him. Like I know you love to go out and do field work. A great way to get students involved in science is to take them out in the field. And I love it when we go on like nature hikes a couple times a year with my lab, and we'll be walking by a stream. And Huzefa is really one of the world's experts in aquatic fungi. So fresh water. There's a limited amount of fresh water on this planet, and there are fungi in there decomposing things. And he's the guy who can like jump in a stream and real quickly start picking up handfuls of samples that we're taking back to the lab. So what do we do in my lab is so they're going to grow those things. We're going to bring him back, or he's going to grow those things back in the laboratory. And my lab effectively tests them against a whole bunch of biological assays and then tries to isolate the compounds that have the biological activity. And the greatest example of this in all of the fungal lore is penicillin. Penicillin, a lot of people say Alexander Fleming discovered penicillin. Yeah, sort of. I mean, I don't want to discount what he did. He did great work, but he was really the guy who made the observation that this fungus, when interacting with that bacterium, seems to be killing that bacterium. And there's a series of other people, particularly a guy named Flory, who was the ones who isolated the compounds that did the chemistry. You could sort of think of like Huzefa's doing the Alexander Fleming stuff, and me and the rest of the chemists in the lab are doing the Flory stuff of like, let's get that compound and put it in a formula that you could eventually, we would hope, turn it into a drug. So That's what we do in the lab. And of course, like anybody who has anything to do with fungi, ever since HBO came out with this show, we're getting phone calls that say, so Nick, you ever seen this show called The Last of Us? I mean, I don't know about you, Huzefa. How many of your friends and mycologists have said, "Hey, man, have you checked this out?"
I mean, mycology, everybody is watching it, right? Everybody is very interested in tweeting about it. And yeah, it's definitely on top of everybody's list. I mean, we mycologists are extremely excited by the show, right? I
Yeah.
mean, I have never seen a show, which was the second episode, where on the top of the bottom of the screen you say mycologist. How many
Ah,
shows have I seen? I have absolutely seen no
Yeah.
movies like that, no shows like that. So I was super excited, and my colleagues, my friends, we're all excited about it. So
Yeah.
so here comes the real question. If you were in this show, would you try and chase down one of those, mushroom infested people and get a sample to extract and isolate a cool drug from them? That would be an interesting
Oh.
twist, maybe a little plot
Oh.
twist. Throw some natural products chemist into the show along with the
Oh.
mycologist.
yeah, that would
Oh,
be cool.
yeah. Now,
Yeah.
I never thought about that. I'm going to answer the question and say, "Oh, yeah." Now, I think Josefa would say to me, "Who's going to go get that sample?" And I can think of few students who kind of drove us crazy over the years. We might send those guys out. Usually they're guys, by the way. Send those guys out to go get the samples. But no, but kidding aside, I think about that show a lot. As I was telling some students recently, I'm no good with a gun. Like, I'm not a hunter. I'm no good with target practice. I'm right-handed, but I'm left eye dominant. I never learned how to shoot properly. So I'm no good with a gun. I'm definitely no carpenter. Um, but I do think that like if the world ends, especially if it was Huzefa and I working together, we could find like plants or bacteria or fungi to work on that we could sort of make medicines for people. So I'd like to believe that we'd be sitting there, you know, in one of those towns where they've built a wall around it. We'd be in a corner coming up with salves, and you'd be just as good at it, Cassie. You'd be really good at that as well. So maybe the three of us could all work together and help rebuild the populace.
I like that, and I am good with a gun, so I could also help with the
Oh,
defense.
oh crap. No, that's good. That's good. I'll
No,
stand behind you.
there you go. But I'm the slow runner, so I have to be.
Oh yeah.
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 But I guess we should, of course, to any of the listeners out there that are regular listeners of Foodie Pharmacology, if you haven't watched The Last of Us yet, there are a lot of spoiler alerts in this episode, so
Oh
just
yeah.
just be aware. Although you may want to watch the show after listening to us chat about it. Basic you kind of break this down. There are people infected with this kind of mushroom, but what's the storyline of the show?
You want me to do it, Zephyr? Or you want to do it?
Yeah, Nick, go for it. Yeah, go
Okay.
for
I
it.
mean, the basic storyline of the show, and I think this is, you know, episodes 1 and 2. I mean, as Josefa said, I almost passed out from how good it was. I think my family was like way in the other end of the house with me going, "You've got to be kidding me!" At the top of my lungs, because uh, a lot of what the show's premise is on, like any good uh, fiction or sci-fi or whatever you want to call it, has got to have a nugget of truth in it, right? And the nugget of truth is that fungi have somehow evolved to now infect humans in a big way, and people do die of fungal infection. So there's the nugget of truth. For instance, I think when you and I were last talking together on a show, I told you that we have a project to study malaria. About a half million people, excuse me, 500,000 people a year die of malaria. It's probably closer to 600,000. I mean, that's a lot, and you could argue that not only is it a lot, it's often children or older people from very disadvantaged places. So there's a lot of work we should be doing in malaria. However, probably about 3 times that. A paper just recently came out. About 3 times that are dying of fungal infections. So that's 1.5 million. Um, the I don't even know what the population of is Atlanta, but 1.5 million would be a lot of people, right, from where you live. And
Yeah.
a lot of times, but the thing with fungi, and I think this is the thing that is hard for like the non-scientist to really grasp. You might say to yourself, "Oh, I got a fungal infection. Let me get an antibiotic." An antibiotic works on bacteria. Bacteria are prokaryotes, meaning they don't have all those organelles and things that eukaryotes do. Human beings are eukaryotes. Fungi are eukaryotes, right? So there's this like very similar things between fungi and human beings that make them hard to target. For instance, we were talking about penicillin a second ago. Penicillin works on bacteria. You cannot overdose on penicillin. You could take the whole bottle, it'd make you sick, you'd throw up, whatnot, but it wouldn't kill you because it targets something that's really only in bacteria. But fungi and humans are so interrelated and so closely related and use similar machinery in the cell that it's really hard to target them, right? So, spoiler alert, they go get a mycologist and say, "Hey, mycologist, can you figure out a way to like treat these fungi?" She doesn't have a good answer for them because there's not a good answer, right? And so going back to what I was saying about 1.2 to 1.5 million people dying of fungal infections, a lot of times it's really hard to count how many people are dying of fungal infections because most of those people have some indication. They've got pneumonia. They're immunocompromised because they've got HIV/AIDS. Um, what are other things, Huzefa? I can't think of.
Cancer
Yes,
Cancer.
yeah,
patients. If you're
Yeah.
undergoing chemotherapy, I mean,
Chemotherapy.
you're yeah.
or they're taking,
Yeah.
corticosteroids and stuff like that.
Mhm.
So the
Yeah.
immune system is suppressed.
Yeah.
That's the key, right? For
Yeah.
fungal infections, your
Well,
immune
Like,
system is suppressed.
we don't have very many good drugs for fungal infections. I think part of the problem, as you mentioned, is that it's so hard to find something that's selective
yep.
to fungi because they're so similar to us on a
Yep.
kind of cellular basis. I mean,
Yes.
I'm thinking about, some of the recent articles that have come also out in the popular media around Candida auris. I
Oh
mean,
yeah.
this is, the super fungus of all super fungi. It has crazy high mortality rates if it gets into your bloodstream. And it's super, super drug resistant. We actually study that one in my lab. So we've been hunting for drugs for it, and it's not easy.
It's
You
not
know,
easy. I bet you
it's
don't
not
have many
easy.
leads, right? You've got a
We've got
few, but
we
not a
got a
lot.
few we got a few,
Yeah.
the one we have is probably best suited for topical use, but we don't have anything good for systemic use yet. And,
Yes.
there's a big difference because some drugs just don't do well in circulation in the body, so it's not just about finding what works in a petri dish, it's also, like, how do you get it to work in the bloodstream? Because that's really where the fungi, when they get to your bloodstream, that's when you're gonna die of some of
Yeah.
these. Yeah.
So do you mind if I sort of throw a question up to Huzefa? Because I think one
Yeah.
thing we should really think about. So I really geek out about like sort of the drug discovery aspects and the failed premise of that within The Last of Us. And like anybody, I would love to believe that if like The Last of Us happened, I'd be one of those survivors. Somehow I would survive. I'd find someone who could shoot the gun well, right? Or I'd learn pretty darn quickly. But I think the other thing is like it's the first episode, so we're not really giving it away. But the opening of the first episode is like the kind of thing that Huzefa and I have been writing grants about. Uh, that the world is getting hotter. Okay. You want to debate global climate change? I think you've lost that debate. Like, I think the world's getting hotter and the human body is 37 degrees Celsius. Most fungi actually don't grow very well at 37 degrees Celsius, but there are a few that grow like gangbusters. Josefa, you want to talk about that at all from like a
Yeah,
think about it from like your transects through Florida
yeah.
and just evolution in general.
Yeah. So for example, like like Nick mentioned, like you mentioned, Candida auris, Cassie. That fungus loves to grow at 40 degrees C, right? Human temperature is 37, so it is already adapted to really warm temperatures. That's why it's doing so well, right? And that's the problem. That's the main problem I see in general. That all the Candida and other fungi, Aspergillus fumigatus, for example, which is another problem fungus that causes aspergillosis, and all these fungi have small spores that'll get into your lungs like aspergillus can do. And it grows really well at 37, so well that overnight you get fungal growth on a petri dish, right? That is scary, right? So the global climate change, the warming temperatures, right? And that's the premise of the show, right? Like, I mean, the world has changed, right? I mean, and you can see this fungus that has now taken over, right? So definitely something that not all fungi can do that, obviously, right? But and Candida auris, one of the reasons it's so successful is that when it emerged, it was already growing. And I just read the species description of that, the first species description of that fungus, and it says it grows really well at 40 degrees C. So that is something where our human body is protecting us from other fungal species, right? Otherwise, we would be really prone to fungi, right? A lot of fungi can grow really well at 25 to 30 degrees C, right? Whereas Aspergillus fumigatus and Candida, these can grow at close to human body temperatures. So that's the scary part.
Yeah, and if I can just interject, when Huzefa says like, okay, you take an Aspergillus fumigatus, and we've done this experiment, you put it in a petri dish, you put it at 37 degrees, you'll fill the petri dish in a night. Let's contrast that to room temperature. Room temperature might take 3, 4, possibly 5 days, right? So, but most other fungi, let's say 90% of fungi, you put them at 37 degrees Celsius, I'm going to argue that they might grow, but they're not going to grow really well. They won't be robust. They're going to be weakened, which is probably how your human body fights these things off. They're weakened, you've got an immune system, and it can fight it off. But the ones that grow really fast are going to overtake. When it was during COVID, the last time we talked, it was during COVID. And, before we had, um, before we had immunization and all that, people were getting on respirators. And you would hear someone sort of say, well, if I get it, I'll just go on a respirator. Let me tell you, you get on a respirator, you're likely to eventually get some sort of lung infection, possibly a fungal infection. 40% of those, you die, right? So, okay, yeah, I got through my COVID, but now you're dying of some fungal infection, which is super hard to treat. So, anyway.
Yeah, especially when it infiltrates deeply like that. I mean, I wanna jump to another premise in the show, and this is, like, the ability of these fungi of in this case, it's all around this concept of Ophiocordyceps, which is different from the fungi we're talking about right now. But this idea that it could survive in the snow. Are there fungi that are like psychrophiles that like cold temperatures? Like, how adaptable? So we know that some of them, like Candida auris and Aspergillus, can go to high, like hot, humid, tropical temperatures. But are there some that survive like in the Arctic? I don't know. Like, is that possible even?
Yeah, I think so. There are fungal species that can grow in extremely cold temperatures. Like when I was doing my PhD, I had a colleague, and we went out and collected fungi, aquatic fungi. We broke a ton of ice to get into the bottom of the stream, right, and isolate a fungus called Tetracladium marshallianum, which is an aquatic fungus. So it grows. It can grow happily at lower temperatures, and there are other strains that will grow in the snow, in very cold temperatures. So yeah, there are fungi that can have a huge range, and fungi are opportunistic, right? That's the thing with fungi. I sometimes joke with friends, like, you go to a tropical environment, if you're immunocompromised, you stand and fungus can grow on you. I mean, I'm from India originally, and I go there, and it's moist and humid, and it's very likely you can get a fungal infection there, right? So that's something happens. And yes, cold temperature, warm temperature, they have an entire spectrum of fungal species. That's why they're very diverse. They're very diverse, right? So yeah,
Yeah. That's amazing. Again, it's like gleaning onto that nugget of truth, like you said earlier, Nick. Like all you need is this little nugget to kind of and then build this fictional story around. Um, okay, so we know that fungi can grow under blocks of ice in the snow. We know that other fungi grow in moist, hot, tropical areas. What do we know though about the fungus that they call cordyceps in the show? It's really inspired by Ophiocordyceps, which is a fungus that I guess infects certain insects and it kind of explodes from their head. I'm probably not explaining this very well. Maybe you can add some extra science behind this,
Yeah,
Huzefa.
yeah, absolutely. And Ophiocordyceps. So Cordyceps was an older name. Now they're called Ophiocordyceps. And you might have, everybody in the audience would have heard of Ophiocordyceps sinensis. It is one of those caterpillar fungi that grow out of the caterpillar. It is found in the Tibetan plateau, and it's used as Chinese medicine. Right, you can buy it, and I think it is like almost equal to gold, the price,
Yeah.
because it's over harvested there, and
In fact, let me just interject for 1 second. In fact, it's some people speculate that it is extinct in the wild. It has been so over harvested, but it's
right,
used in this traditional Chinese medicine sort of way.
right.
Um, but it's not one that you can grow in the lab very well. You've got to get it from the caterpillar. That's the
Right.
problem.
And then there are people trying to grow that, and they're making efforts to grow it, because if it's selling, you want to grow it and make money from it, right? So the one that grows in insects also Cordyceps. Basically, it infects different orders of insects, about 20 different orders. There are about the estimates are like there are 600 or so species in the wild, but they've only discovered about 200 of them, and they target different kinds of insects, right? Ants, for example, different species of ants and different kinds of insect orders, right? And they specialize on them, right? And they sort of they're like specialized killers of these parasitize these insects and killing them in a way that is like evolutionary specialized, right? So you have these different species that work on different kinds of species of ants, for example. And if you draw a tree of life, you can see that they have specialized on each of these different insect species, right? So you then they have different fruiting bodies coming out of their heads. Basically, what happens is once the insect gets infected, it sort of comes out of the nest. For example, ants they want to weed the infected ants out, right? So they come out wobbling and they go on a higher surface which has more humidity, and then from there they sort of shed their spores and they feed on the insect's body essentially, right?
So this is like where the idea or the premise of
Right,
infection with this fungus turns you into a zombie. I mean, that's,
right,
we're talking about like
exactly,
fungal controlled zombies in this
exactly,
show.
exactly.
Um, so so in reality though, what you're telling me is that when this genus of fungi infects insects, it does kind of take over their it does kind of zombify them. They behave differently to get to the optimal areas for the fungus to continue growing. It creates a fruiting body, and a fruiting body, by the way, is basically what we think of as the mushroom top, right?
Right,
The not the mycelia, the mushroom, and then poof, out come these
correct,
spores and infects the next group. So that's just wild. I mean, I love how they took that nugget from nature and put it into humans, but
right.
is it even possible? Like, are there cases or is it known if cordyceps or Ophiocordyceps can infect a mammal, or is it just restricted to insects at this time?
No, I
Oh,
think
that's
right now it's only insects. That idea is kind of far fetched. It's not happened. But when you look at fungi, and let me point out that zombie-like behavior with Ophiocordyceps is only a few species can do that. Not all Ophiocordyceps make the insect like zombie-like behavior, and they basically take over. They germinate through their exoskeleton, get into the muscles, right? They're controlling their muscles, and that's how they're sort of controlling the insect, and there are studies where they've shown that it doesn't really go into their brain, it's just controlling the muscle, but it's implicated that small molecules probably are implicated in their in a movement. But for example, in other fungal species, you have there have been noted that for example, Masospora is a fungus that affects cicadas, right? That story was big recently. One of the mycologists, Matt Kaysen from West Virginia University, studied it, and they found that they were injecting these cicadas with amphetamine and psilocybin-like compounds, right? So to control their minds, like to control their behavior, right?
Wow. So
So
psychedelics and stimulants.
yeah,
Yeah,
exactly,
and let me
exactly.
interject one other thing because we keep talking about these nuggets of truth. Let me make sure we'll ask Huzefa. I'm pretty sure that it is only a few insects that actually get their bodies taken over, if you will. But I believe that they don't propel themselves properly, right? Don't they kind of walk a little messed up, not like a normal ant?
Right,
And that
right.
and that is one of the things I do love about the show is that when the humans are infected, it's not like they're just walking down the street.
Yeah,
They're kind
right.
of it's almost like their whole body just doesn't quite work right, but they can still propel it forward.
Yeah,
Sometimes like a dog, sometimes like a human, sometimes like
yeah,
almost like a bird.
right.
And I think that little nugget, that's pretty good. Like
Yeah, oh yeah.
that took someone to really think about it. I loved it.
Yeah, no, no, absolutely. Yeah, they sort of have like different movements of
Yeah,
walking out and trying to attack you and stuff. So that's great. I love that part of it. It's really
yeah,
cool.
yeah.
So, Mustafa, are the insects still technically alive? Like they're living, they're still alive. They just completely lose control of their body and they're getting chemical signals from this fungus that's forcing its muscles to contract in this kind of weird
Right,
way.
right.
Or they're getting like psychedelic type compounds
So
or stimulant like amphetamine to like, so they're totally drugging
yeah,
the body of the insect in some way to behave the way that's beneficial to the fungus.
right. In the case of Ophiocordyceps, I don't think there is evidence that they make these kind of compounds to control their mind, but other fungi do that, right? That's another thing I was saying. Cicadas, for example, cicadas were recently in the news, and the fungus that I was mentioning was Massospora. It's a fungus that can do that. It can, and, and fungi are capable of making these compounds that can control. But in case of Ophiocordyceps, the Last of Us show, I don't think they can make compounds. We don't know, at least they may be making small molecules, and we would love to work on that, right? We have techniques where we can try to look at in situ little heads
Oh
of
yeah.
the ants and see if there is small molecules there, right? We would
You
love to
have to
do
apply
that.
for a grant for this.
Oh
This has
yeah.
got, I
Yeah,
mean,
Yeah.
yeah,
it'd
that
be
would be
so
HBO, man.
interesting.
Would HBO give us a grant?
yeah, yeah,
Yeah.
exactly.
Well,
So
It'd
the
be,
so
nice thing to think about it, Huzefa can like weigh into this, like you can steal ideas from the entire fungal kingdom for HBO, right? But fungi are hyper diverse. We have a colleague at the Vanderbilt University who studies evolution in fungi, and he often makes the point two fungi that have a very similar name, right? You and I would think, oh, they're as related to us as like you and as humans are to primates, can actually be like super diverse, like the relationship between birds and fish. Am I right, Huzefa? Do I have that right?
yes, yes.
Yeah, that it's just so much diversity out there. So even though we all think of it as fungi, and Huzefa and I can get really down into the weeds of like, are they basidiomycetes or ascomycetes, which most listeners are not going to care about, but what you eat from the grocery store is a basidiomycete. And I think the cordyceps is actually an ascomycete. Am I right? Yeah,
Ascomycetes,
it's an
yes,
ascomycete.
ascomycetes. Ophiocordyceps is ascomycetes, and ascomycetes also morels. People love to. It springs around the corner. People love to hunt morels
Oh
and
yeah,
eat them. So they're also ascomycetes, right? So, but they're how you can see how diverse they are. One's like parasitizing insects, and then the other one you're consuming, right?
yeah,
So and so
yeah.
and so it's the diversity, right? It's unimaginable diversity out there.
Yeah.
okay. So The Last of Us is certainly not the first, I guess, Hollywood production that centers around a concept from fungi. I'm thinking, of course, of Avatar,
Mm.
right? That was also kind of inspired by, I think it's Suzanne Simard's work, looking at kind of this, they call it the world, is it the world or the wood wide web,
Yes,
right?
yes,
Where you
Mm.
have this intersection of mycelia, of fungal mycelia under the ground. There's entire networks. And the idea was that perhaps communication is also happening beneath the ground through these fungal intermediaries. We saw some of this come out in the show, right? Where they,
Yeah.
the mycelia could kind of sense movement, or they could kind of communicate and say, hey, there's, food coming your way. I was just wondering if you guys could talk a little bit about that, around like how organisms communicate through secondary metabolites, and how much of a nugget of truth was there in that kind of fungal communication showcased on the show.
Oh, I have to say, I loved that component. That was another moment where I was like, "Oh yeah, that's awesome." This fungus way over there is talking to that human being, right? Pseudo human being. Um, you know, I, I'm just thinking about some of our own studies, Huzefa, like where we're looking at, we study one fungus that produces an antifungal compound. It's actually an FDA approved drug. We didn't discover it, it was discovered way back in the 70s. It's called griseofulvin. And we've done studies showing that the fungus will send that molecule to the periphery. So like when you grow fungi in a petri dish, they kind of grow in a circular format. So it sends it out to the periphery. It kind of makes sense because you can imagine as the fungus is trying to grow, it wants to push other things away. Interestingly, though, we did a study once where we had a fungus that it was competing against. So there's a fungus on top and then the one that makes the antifungal on bottom. And if you sampled around the periphery, the molecule that's got antifungal properties was really only headed up towards where the other fungus was. I have no idea how it knew that, right? It can't see, it can't hear. So there's some chemical signal saying, because you got to remember, nature is going to try to preserve energy. Everything takes ATP, which is like energy for us, right? And somehow it's deciding, don't send it south in that dish where there's nothing down there. Send it north where we've got to go fight this other fungus. Josefa, you want to weigh in on that? You
Yeah,
remember
yeah,
that experiment?
we saw that in our research, and we it was very interesting, right? And the way the fungi grow, basically, right, for the audience, they're basically growing inside out, right? The outer part of the fungal mycelium and the hyphae are the youngest, right? So it's basically going in search for food, right? You can imagine you have the fungus growing almost like a snake from inside, and it's going everywhere it sees food, right? It's just growing towards the food, right? And so that concept was really well taken. Like it can sense where the food is, and it's going towards the food. And in this case, a human is coming, and so these guys are all waking up and going towards the food. And the way they do it is like, fungi have their digestive systems inside. Like we eat food and we digest it in our stomachs, right? Fungi, what they do is they eat their food outside and then they take them in, right? So it's like an inside out digestive system. They secrete extracellular enzymes that go and break down the food, and then they take the food in, right? That's how fungi grow. So I think basically that's the way they communicate. That's the way they're growing. And what we've noticed is when we grow fungi in the lab, when we give them a media that are not very rich in sugars, they will grow out, right? They're going out, like they're trying to reach. And sometimes when we give a lot of sugar, for example, potato-based media, it'll grow like very closely because it doesn't really have to spend energy, like Nick said, right? It's
Yeah, it
it's
doesn't have
just
to
a couch
forage, right?
potato. It's
Yeah.
not, and that time what they do is also they don't produce small molecules, right? Because they don't need it, right? They don't need to spend the energy to make the secondary metabolites, right? So that's the way these guys grow. Yeah.
Well, I think this speaks to, I think, a common misconception that people have both about plants and fungi. I think many see plants and fungi as static, unmoving creatures when in reality they're incredibly dynamic. They are communicating constantly with, they're sending out cells, at least for the fungi are sending out cells to get to the resources they need. Plants are sending out signals to other mobile creatures in the environment to get what they need. um, I just
Right.
think that it's incredible. There's so much chatter. There's this chemical chatter happening. It's a whole other set of languages that we're
Yeah.
kind of not really tuned into yet, but we're getting better at it, right?
Yeah.
Through chemical detection, analytical chemistry techniques. But man, if I had a magic power, and maybe this could be, an idea for a future show. It's like, if you could learn to somehow tap into that language of nature, to be able to interpret and read what the plants are saying to each other, what the fungi are saying to each other, that would be pretty cool.
Yeah, and and there's as you know, you often study what I call folkloric things from plants. I can remember so that concept. I forget the name of the woman who came up with the concept of the wood wide web. What is that? What is her name?
I think it's Suzanne Simard.
Yeah. So I
Mhm.
remember reading about her and thinking about my own grandfather, actually my great grandfather. We were transplanting trees once, just small little trees moving around his property, and he was almost obsessed with like take some of the dirt, not just like the dirt that you need around the root ball. He would take like almost like a little coffee can full of the dirt in the area and throw it in the bottom of the new hole. And his argument was, well, that helps the tree grow, right? He just knew that if you're going to transplant this tree, you need to bring some of the dirt that it was growing in. Well, obviously, he's doing an experiment. Now, looking at it now, the obvious thing is he's doing an experiment where he's bringing the microorganisms from that soil to this new spot that we want to give it so that it's kind of like the fungi, the bacteria, the nematodes, the worms, whatever else is in that good, rich soil are communicating with this new little sapling that we're trying to get going, and trying to give it a little boost, right? I mean, that concept, which I think many, many people know about if you talk to somebody who plants trees, is certainly based on this concept of like organisms communicating with each other mutually, beneficially.
No, for sure. I mean, it's all about this communication. So we've talked about lots of things that we loved in the show. We loved some of the different nuggets of truth as we've discussed, but were there things that you didn't like about the show? I'm curious. Like, what were things that you're like, no, they should have done it a little bit differently?
I've got two things I'll say, and then I'll let Huzefa weigh in because I think he can geek out way more on the mycology. The two I, I have to say I don't love the violence. Okay, like I mean, it's based on a video game, and there are moments where I can see where it's going down this video game route. But what I mean by that is it bums me out that like this one, like let's call it a tribe or group of humans, suddenly doesn't trust that tribe just because they don't know each other. I would like to believe there's so few humans out there. Shouldn't we all be, a happy little family and repopulating the earth or forming little communities? Like that kind of bums me out. And I guess that wouldn't make for good drama, right? So I get it. They need that. But I don't love that. But I think from a mycology perspective, the one thing that I think is again, it works for the show in a way I'm not going to give away for the last episode, but people get bitten and man, they're infected quickly. It seems like they know right away, they can maybe see something on their skin, and then they're going down this deep dark path within 24 hours. And while some fungi, we just told you, like some fungi will grow really well at 37 degrees. Boy, human beings a pretty big thing to infect and really take over. So um, I guess again that wouldn't work. We can't just have people waiting around for 45 minutes on the show. We need drama, but it was a little too quick for my taste. Fungi typically don't grow. One reason people don't study fungi as much as they study bacteria. E. coli replicate like every 4 hours. Is that right? Is that like the doubling time on E. coli is far quicker than even the fastest fungus, right? So you want to study them in the lab, you got to spend a little more time. And yeah, they've accelerated that for the show.
Yeah,
Go ahead,
yeah,
Huzefa, weigh
I
in.
agree with Nick on the violence part. I was not a big fan of that. I also do not play a lot of video games, so all the shooting and all of that was But for me it's a fantastic show. I cannot complain. I absolutely love the show, and I would be like, it'd be nice to see more zombies in the show. Sometimes there are episodes where we don't see a lot of fungal zombies happening.
You're like too much drama in humans. Where's the
I'd
zombies?
love
Show
to
me the fungus.
It's funny.
love to
I'm the
have them.
opposite.
Yeah,
I love it.
yeah. So I'd love to have the fungal zombies in more, but I know that if that happens, then the shooting is going to increase, Nick. So, but
Yeah.
I
Yeah,
love the show. I absolutely love it.
I loved it too. I have one thing though that bothered me. It was the reliance on this gross old canned food. Okay, yes, they had a few scenes where there were hunters getting rabbits and things, but where are all the foragers? Like, they're walking around this area with so many wild foods right
Oh
there. I
yeah.
mean, fresh greens. I mean, people would just be super malnourished with the kind of foods they were relying on, or just you can't just, or relying solely on agriculture when they're trying to make these transitions. But I'm like, dandelion greens, you know, hen and chicks, chicory, wild
Oh yeah.
fruits. I mean, there's just
Oh
so
yeah.
much. And I was like, and then they're going to these like old cans of Chef Boyardee. I'm like, oh man, there's so much they could have done to like educate the public about wild foods that would have been so cool. So that's my one criticism. And maybe if someone out there, one of the writers in the show, if there's any chance you're listening, please get some foraging into the next season because I think that would just be so amazing.
You
Yeah,
could put
because
a twist on that too, right? Because like,
yeah.
would you forage mushrooms or not? Like everyone's probably pretty
Oh,
freaked out by fungi now, but there are quite a few fungi you can eat from the wild. We were talking about morels and things like
yeah.
that. But would you be like, oh no, I don't want to eat that? I don't know.
Yeah. Yeah, that's a good twist. It's like, which of these do we eat? I don't know. Um
Mycologists always say bad taxonomy kills. So you want to be careful. You need to know your mushrooms, right? So
yes.
Oh
you
yeah.
need to know the taxonomic names. You don't want to make sure you don't want to eat anything that's not identified incorrectly, if you will. So I think that's very important. I'm sure it's
Yeah.
in the plants, right?
Yeah, well, I guess they don't have the internet any longer either. So it's like it's not like they just Google, "Oh, is this the right," or put it onto one of the apps to see if it's the right plan or not. But you could always go to a library and like raid for like their foraging handbooks. I mean, I think when it comes to there are some very common plants that you could and fungi that you could just stay away from any that have very, closely related lookalikes. There are plenty of things that don't have you know, such a source of confusion, but
You
I
know,
don't
and
know.
I think one thing I kind of like, if we go with the converse of that, and I'm thinking about the fact that in the background behind you is a whole bookshelf of books, and there's some behind me. And if you go down to Huzefa's lab, lots of books. Like I do like the fact that like maps are now super precious. and
Yeah.
where you
I
are
don't
on the
own I
map.
don't own maps. I don't own
Exactly.
maps. Yeah, that's a good
Yeah,
point.
and book like, even books,
And
even to
books.
kids,
Mhm.
like, there's a book that's like, "How did you get that book?" "Where did you
Mhm.
find that book?" Right? And now, what? You could get a book delivered to you in 24 hours or less, right?
Yeah.
So, I would love to believe that maybe there's a little bit of appreciation of like, "Hmm, maybe we should be reading." But maybe that's the professor in me who gets annoyed with all the students who just, Google everything, right? So
So what's the takeaway? I think the takeaway is if the end times comes and there's a fungal apocalypse, you should definitely try and find our little village.
oh, yeah.
Yes, yeah.
We would have a great one. We would have a great village, man. No one would
No
be infected.
violence.
Yeah, no
Lots of
violence.
great things to forage and eat.
Yeah, yeah.
Medicines from plants. We'll have you covered. So
Medicines from
Still
plants, we
have
would.
the streams, Nick. We'd had I can go collect fungi
Oh,
from
yeah.
streams, and we can
yeah,
Yeah,
you
share it
guys
with
can
the
find the
chemistry.
next cure. I mean, it'll be great.
yeah. We could recycle cures. Like, I mean, we all know the
Yeah.
natural products history. We'll just recycle it. People think we were geniuses. Like,
Oh my gosh.
wow, what is this
Mhm.
thing that's fighting this infection? Oh, I don't know.
Wait, shh, don't give away the secrets for the future here.
Yeah.
Oh my gosh, this has been so much fun. I wanna thank you guys for coming on the show. Yeah, maybe we'll have to revisit for next season if they come out
Absolutely.
with another season because
Yeah.
and I swear if they do have some foraging in the next season, I'm gonna lose my mind. It's gonna be so awesome.
I love it. Hey, I had a great pleasure with it. As everybody in my world says, like, we love this, just as Huzefa said. So
Yeah, I
thank you for
love it.
having us.
Absolutely. Thank you for
Yeah.
having us.
Yeah, thank you. All right, foodies, you've been listening to Foodie Pharmacology, the science podcast for the food curious, recorded for you today on Restream. I want to thank our amazing producers, to Rob Cohen and Christine Roth from Co-Conspiracy Entertainment, for putting on a fabulous show for you all every week. If you want to help us out with production costs, you can do that two fabulous ways. You can head over to Buy Me a Coffee. I would love to get some extra caffeine into my day. It's at buymeacoffee.com/foodiepharma. Or if you're interested in getting some fun swag, we have amazing coffee cups and bags and t-shirts and all kinds of cool things with Foodie Pharmacology logos on it. And you can find those at mysterycontrol.com. All right, that's our show for today. Stay healthy out there, and I'll see you next time.